Hello, welcome to another briefing. So in this briefing, I wanted to talk a little bit about inside slider storm systems and what they are. And so I want to start out by showing you this graph, not a graph, but a depiction of what the La Nina weather pattern tends to look like. This is courtesy of NOAA. And what it shows is basically a big blocking ridge of high pressure over the Pacific, with the polar jet stream extending way north over parts of Alaska, and then dipping down from Alaska to through the Intermountain West of the United States, all the way down through Canada, Intermountain West of the United States, into parts of the East Coast. Now, this can still vary. This is variable throughout the season. This isn't what it looks like during an entire La Nina year. And then the Pacific jet stream, also pretty variable. And most precipitation tends to be concentrated in the Pacific Northwest, with also snow and precipitation in the Intermountain West, with inside slider type systems, where they come from the north and they're typically colder and drier. They don't pick up a lot of moisture off of the ocean. They're not like those systems that come from the ocean onshore into the west coast, and they pick up a lot of subtropical moisture and slam into the west coast. That's what we had a couple years ago. Anyways, we are expecting a weak La Nina event this year. It might even be a neutral year. There's still a lot of uncertainty around that. It might, and if it does end up being a La Nina, it'll likely be a very weak La Nina. And so don't take this as a rule of what will be happening, even if it were stronger La Nina. Don't take this as a rule for what the pattern will look like the entire season. This is not meant to represent what the weather pattern will look like during a La Nina for the entire season. This is still variable. We can still have coastal systems come in. We can have this big ridge shift east. We can have a coastal system come in and bring rain further south as well. But this is just what it typically looks like. And so far this wet season, which has just begun, we're not at the peak of the wet season yet. That doesn't happen for another 2 to 3 months. But we are starting the season, and the pattern we have seen so far has looked a lot like this, although slightly different, and I'm going to show you that right now. So see how in this classic La Nina depiction, the center of the high pressure ridge aloft is basically over the Gulf of Alaska? In this case, it's in what's happening now, it's actually a bit further to the south. It's actually off of the west coast of the United States. So that Pacific jet stream has not been very active, because this high pressure is actually pretty much right off of the coast of California. But I'm going to show you what's going on right now. See, this is what's going on right now. I even did a little depiction here to show you, so you could better understand this weather map. But what we have going on this week is pretty much that system, that pattern, except the ridge is a lot further to the south, so there's actually a deep trough of low pressure over the Gulf of Alaska, and that jet stream is consequently, because of that ridge being further south, that jet stream is also further south than in the depiction. Instead of it going through, say, Idaho, Montana, what's been going on is it's been going more through the Pacific Northwest down into California, inland, eastern California, pretty much Nevada and the Intermountain West. So it's a little further south. So that means we are actually getting some precipitation down to parts of Northern California, but we're not getting a lot of precipitation beyond that, and that is because the nature of these systems, they're very cold and dry. See, the track they take is a very inland track. Like when it gets to the Pacific Northwest, it's coming from the Gulf of Alaska, that's still pulling in enough moisture. So places like Seattle and Portland get decent rain. But when that thing slides inland, by the time it reaches the latitude of the Bay Area, for instance, it's so far inland that it's not pulling in a lot of moisture. It's not pulling in a rich southwest flow of moisture from the ocean. If this low pressure system were way out here, the wind ahead of it would be southwest, but we get the back end of it. These are backdoor systems, also known as backdoor systems, because they come in the back way, and that way they tend to be a lot drier. There's still usually enough lift with these things and enough moisture for precipitation in the mountains, and snow levels can be pretty low, particularly when these occur in the core of the winter months. But the downside is they're a lot drier, and they don't usually bring a lot of rain to the coast and valleys, if any rain in some instances, depending on exactly where they set up. The further inland they are, the drier they tend to be for coastal areas. So it's not the ideal pattern if you want to see good rain in the Bay Area, but this is pretty much what we've been dealing with so far, and this is also very reminiscent. If you look at these side by side, this is very reminiscent, just slightly different, but it's very reminiscent of what a La Nina pattern looks like. So, I'll definitely be keeping an eye on this. Hopefully, this does not hold for long. Hopefully, we do eventually get some change. And actually, there is a little bit of hope. I'm actually going to show you that right now. So, look at this computer model projection. This is the GFS projection for the jet stream winds. It's about 30,000 feet up in the atmosphere over the eastern Pacific. You can see the west coast. You can see the western states of the United States here, even the Intermountain West depicted. And see how with this first system that comes through this week, it's a west-southwest flow, but pretty westerly. I mean, maybe west-southwest at best, but that's not going to pull in a lot of moisture. And I was just, if I go, okay. Because I wanted to show you the moisture map, but, actually, I can show you that next. So, you see, this is a pretty dry system. It's pretty much northwest winds as we go into tomorrow. This is straight northwest. This is very dry. It's not very significant for rain. See, when you see the leading edge, it's not really pulling in a lot of moisture. Come in the next system on Halloween, similar kind of thing. Look at that. It's even drier. It's just west, maybe even a little west-northwest. There's no southerly component to this at all, as that cold front portion makes its way down. See, that's a dry system. That's another dry inside slider. But look at what happens further out. So this is the third, fourth, maybe another inside slider, but look at what's brewing. Look at this as we go in towards November 9th and then the 10th. But this is even just looking at early morning November 9th. Look at this. South flow. Look at this trough over the ocean. This is a much more favorable path for getting significant rain and moisture. I'm going to show you a different map here. You'll get a better idea of what the rain projection is. And look at this. This is a nice, juicy, wet system. This is far out there in the forecast, and a lot could change until then. This is a deterministic forecast based on the conditions as we best understand them today. And this is about 2 weeks out, looking 2 weeks in the future. So a lot could still change. Don't take this for granted. Don't take this too seriously yet. Don't take this as what will exactly happen, because a lot could change, but it's a signal. What this is at this point is a signal that we could have a nice, wet, juicy system by November 10th. We'll see if things line up, but I'm just going to show you. If I compare this, look at this. This is the Halloween system that we have coming up. Very dry. As I showed you, the winds aloft were very westerly. I mean, that shows here. It's a very dry system. It's an inside slider. Another system on the 3rd into the 4th. See? Maybe some snow for the mountains, but that's it. Like, nothing really for the coastal valleys, precipitation-wise. And then you see another inside slider into Canada, and then there's some ridging for a while. It's dry, but then here comes that wetter system potentially around the 10th. So definitely we'll be keeping an eye on that. I'm going to show you the water vapor, actually precipitable water map, and I'll show you the difference with that too. So look at this system on Halloween. All right, this is maybe about 7/10 of an inch of precipitable water, like, which would mean like the hills that squeeze out the most rain would be maybe like 7/10 of an inch or something. Like the most, like, if you were to squeeze out all the water in the atmosphere, this is what you would get. That's not a lot. That's not very significant. It's a pretty dry system. You see the ribbon, you see that moisture, how when it gets to the Pacific Northwest, it's okay, and then it kind of just fizzles out. There's not a stream of moisture from the southwest. Then let's look at the next system. See, similar kind of thing, not a lot, even less actually than that Halloween system. But look at that. Look as we go in through the 8th, 9th, 10th. Look at that. These green here, this green color here, that represents over an inch precipitable water values. Right. If I were to pull the numbers here by looking further in, look at that. That's over an inch. That's a significant little flow of moisture. Now, that's still to be determined if this will verify. This is still over about 2 weeks out, but it gives hope. This gives me hope that we could get a decent system with a good tap of moisture. Because if you compare it, there's just almost no comparison. I mean, you compare this to the Halloween system. Like, most of the moisture is well offshore. You get maybe for a little bit, you get almost an inch precipitable water for Half Moon Bay. But look at this. This is a lot of, like, light blue. This is not very moist. Look at the difference. I mean, look at the difference. Look at widespread green, dark blue to green. Look at an inch value. Like, this is what we want. We don't want these dry inside sliders with just like a thin ribbon of moisture here. This isn't really, there's not a lot of lift associated with this. There's not a lot of moisture aloft associated with this. If I show you the moisture aloft, look at 18,000 feet. Look at this. This is a joke. Look at this Halloween system. This is actually before the system arrives. There's moisture, but there's no lift to work with that. And then when the main front comes through, I mean, this is wild. This is dry. This is dry. See, then we get some ribbons of moisture, but you need the lift to be associated with that. But if we look out, look at this. Look at that. That is the potential system on the 9th. And that is what I am talking about. This is what we need. A deep, rich flow of moisture. This, you look at that and you go back to this, and this is like, And this isn't even, I don't know if this is even lining up with the system that we're supposed to be. Yeah, see, it doesn't even line up with when the actual front comes through. Look at this. Like, look at this. This is meager. Look at this. And then you go, look at that other system that we're expecting. See, this would be a lot more significant. So, hey, fingers crossed that this verified. We'll definitely keep an eye on this, and I hope this was a helpful explanation of Insight Sliders and also a little sneak forecast of what's to come.